While driving down the highway, traveling at 24 meters per second, you decide to get into the left lane to pass the car that was in front of you that also is traveling 24 meters per second. You step on the gas and accelerate your car at a rate of 1.5 meters per second squared. You pass the car after traveling 250 meters. How long did it take you to pass the other car? So I took all of the information in this problem, pulled it out, put it in a picture, and pulled the numbers out a while. Here's my car. I know my initial velocity was 24, and I'm getting faster, faster, and faster. That means my acceleration is in the same direction, and I was given at 1.5 meters per second squared, and I know it's going to take me 250 meters to pass the other car. I have my 5 things. Displacement's 250, initial velocity is 24, acceleration 1.5. Time is what I'm looking for, so I want the equation that does not have VF in it. That's the third equation. D equals V naught T plus 1/2 AT squared. Unfortunately, V naught is not 0 and D is not 0, so we're going to have to do the quadratic formula on this equation to solve for time. So I have to rearrange this so that it's set up in the quadratic formula basic equation. If you're not aware, that is 0 equals ax squared plus bx plus c. So I have to get 0 over here. So I'm going to subtract d to the other side. And what will happen there is I'll have 0 equals, I'm going to flip-flop these two terms to get my t squared over there, because in this case, t is the x. So that's 1/2 acceleration t squared plus v naught t minus d. You might notice there's a slight difference here. That's okay. So my a term, when I set up my quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a, my a term is 1/2 acceleration. My b term is v naught, and my c term is actually negative d. So when I take my quadratic formula equation, which is negative b plus or minus the square root b squared minus 4ac all over 2a, that would give me x. Using this equation, the physics equation, and plugging in 1/2 acceleration for a, v naught for where b is, and negative d for c, this is going to look a little bit different. It's going to be negative v naught plus or minus the square root of v naught squared plus 2ad all over the acceleration. That will give us time. If we plug in our numbers, negative initial velocity, so we have to come back over here. Negative initial velocity is negative 24 plus or minus the square root of 24 squared, because that's our v naught squared, plus 2 times the acceleration, which is 1.5, times d, which is 250. And that's all over the acceleration, which is 1.5 meters per second squared. If I plug that into my calculator, I'm going to get time. And you might remember from math class that if I do a quadratic formula, I'm going to get 2 numbers for time. If I do the plus, so negative 24 meters per second plus this stuff, what I get is a time of 8.3 seconds. If I plug in the minus, t would equal negative 40.3 seconds. Well, we can't have 2 times, and also we can't have negative time. So what that means is this one doesn't make any sense whatsoever, and the correct answer is it takes 8.3 seconds to pass the car.